Welcome to The Explainer. Today we're diving right into what is arguably the strangest discovery in modern AI. Honestly, it's this single fascinating concept that literally defines the whole story of artificial intelligence over the past few years.
Okay, let's jump right into this. For years, the secret to making these models smarter, well, it wasn't some incredibly complex algorithmic breakthrough. Nope. Researchers simply made them bigger. And the crazy part, it just kept working, way longer than anyone expected. It really comes down to this. No single clever breakthrough, just more.
So let's rapidly recap what bigger actually means in this context. It's basically scaling up three core things all at once. First, more parameters. Think of these as the billions of internal knobs the model can adjust. Second, more data, like training the model on a massive chunk of the entire internet. And third, more compute, just throwing raw, massive processing power at the training process.
Now, when you push all three of those dials up together, the models don't just get a little bit better. They get predictably and reliably better. This right here is the absolute foundation of the famous scaling laws. Basically, performance improves in a smooth, totally forecastable way as you scale parameters, data, and compute together.
But wait, here's where it gets truly astonishing. As these models crossed certain massive size thresholds, they suddenly unlocked what we call emergent abilities. It's kind of like, well, think of water suddenly boiling once the temperature crosses that specific threshold. The state just fundamentally changes in an absolute flash.
Now, what's really interesting about this is the specific skills that just bubbled up out of nowhere. We're talking basic arithmetic, translating between languages it was never explicitly taught to translate, writing working code, heck, even explaining a joke. No way did anyone actually program them to do these specific tasks, right? Smaller models couldn't do them at all. They just appeared.
Think about the sheer, ridiculous paradox of this for a second. The model's entire training objective is deceptively simple. Just predict the next word in a sequence. That's it. Yet, by doing that one incredibly simple thing at a massive scale, the system somehow develops something that looks remarkably like reasoning and genuine world knowledge. It's wild.
It brilliantly illustrates the sheer irony of this whole era. Bigger didn't just mean more of the same. It actually meant genuinely new kinds of behavior. Just by trying to get really good at playing autocomplete, an entirely new level of intelligence spontaneously unlocked.
And this singular, powerful realization is exactly what set off the massive AI race you've been reading about lately. It triggered these enormous financial investments, a completely relentless push for ever larger models, and this huge global scramble for the computing power and data needed to feed the whole shebang.
Now, to be perfectly clear, and let's stay grounded here, scale is absolutely incredibly powerful, but it's not infinite magic. Researchers are actually out there actively debating its absolute limits right now, questioning how far sheer scale can ultimately take us. It definitely isn't an endless guarantee. So, the crucial point we need to take away is this deeply humbling core lesson that really defines this era of technology. Sometimes, in AI, more really is different. You make the thing big enough, and it just starts doing things you never taught it to do.
Which leaves us with a final, thrilling question to ponder. If making a model big enough means it literally starts doing things you never explicitly taught it to do, well, what completely new, unprogrammed capabilities are going to emerge as these systems grow even larger in the years to come? Thanks so much for joining me for this explainer. I really hope it leaves you as absolutely fascinated by the architecture of emergence as I am.